ask questions. I will have time during the presentation to address questions. If they're topics that I'm going to be covering, then we might just wait until that part of the presentation, but we'll play that by ear. And Crystal, if you wouldn't mind just watching the list and making sure I don't miss anything. I have to admit that I had a very sleepless night last night, so my eyes are open because I've been consuming large quantities of caffeine, which is kind of what we sign up for in consulting. So sometimes that's just the way that the game is played. I do appreciate your answers to the poll questions. That gives me a really good idea of kind of where you are in terms of your experience with Power BI and related technologies. We included analysis services, tabular in those questions because the technology is really the same. That's what Power BI is built on top of. We'll talk about that a little bit. You know, another question that we should add to our polls, Crystal, is what time zone are you in? Because I'm interested in how many people will get up for an 8 a.m. Webinar versus an 11 a.m. webinar, or perhaps in Europe or parts of Asia or somewhere else in the country. Let's go ahead and get started. The title of this presentation is Data Modeling Solutions for Challenging Data Model Problems. And this is primarily focused on Power BI, but this also applies to SQL Server Analysis Services tabular models. Power BI is actually built on top of the Analysis Services tabular engine, what is internally called the Vertipack engine. It was part of an internal project at Microsoft some 7 or 8 years ago called Project Gemini, and it is an in-memory column store tabular data modeling technology that essentially takes data, places it all in memory, compresses each column in every table, defines relationships, and that is the modeling engine that Power BI uses, Power Pivot in Excel, and Analysis Services tabular. And then we have flavors of Analysis Services both in Azure and on-prem. So that's what we're going to be talking about today. But my examples will all be using Power BI. I am a lead consultant. We just renamed all of our roles at Pragmatic Works. Formerly, I was a principal consultant, now lead consultant too at Pragmatic Works. I've been with Pragmatic Works full-time for about 2 years, but I've worked with Pragmatic Works for many, many years. Great organization for both training and consulting in the Microsoft Data Platform, Azure, and business intelligence space. A member of the Microsoft Data Platform MVP program, the MVP program is a Data Platform MVP. And you are welcome to subscribe to my blog. This is my personal blog at SQLServerBI.blog. We also maintain a very active blog and host free content at Pragmatic Works, as well as subscription-based training. I will mention that if you've been affected by the COVID outbreak, if you've been furloughed, if you are a job seeker because of companies that have been struggling with the outbreak, Pragmatic Works is actually offering free training for those individuals. So reach out to us through our website. And I tweet at Paul_Turley, and so you're welcome to follow me and connect with me. I'm also on LinkedIn. I just didn't list all that, my contact information. So this is essentially how I described this session, and we're going to jump right in and talk about different modeling techniques. Now, there are a number of business intelligence products in the industry. 5-6 years ago, we really saw a surge in self-service BI, meaning rather than business intelligence, reporting, analytics, and decision support tools being part of IT, the traditional approach where the business needs reports, the business needs dashboards they need to interact with and analyze and learn from data. So they go to IT, they dictate business requirements to maybe a business systems analyst. Developers then build an ETL process to populate a data warehouse. They build a semantic model, they build reports and visualizations, dashboards on top of that. A lot of those tools now are in the hands of business users through tools like Tableau and ClickView and Spotfire, and there are a number of tools that have become very, very popular in the industry. Pros and cons there. One, importing some data and throwing it into a chart, easy thing to do with a variety of tools, including Power BI, including charting inside of Excel with Power Query and Power Pivot. But most of those tools promote the idea of importing data, maybe mashing it together into a single table. And in the view of the casual data consumer, the world is flat because they primarily use tools like Excel. And in the world of Excel, generally what we do is we bring data together into a flat table. So we look at this example. This is real data from a sample database that I'm going to be using. But if I were an Excel user, I would most likely bring that into a worksheet, perhaps a table within a worksheet. Let's analyze this a little bit. You can see that there are 3 separate date columns that describe retail orders, the date that the order was placed, the date that it's due, the delivery date. This is very, very common sample data that we've seen in a number of databases. Then we have some customer information. So here we have the customer name, we have the customer key. I've simplified this. We might have other attributes like the name, the address, the zip code, the country, etc. We have some product information, and again, in the simplified view, we've got the category, subcategory, and product name, and then we have some numeric columns, and we'll call those measure columns, numeric columns that can be aggregated, whether they're summed or averaged, min, max, whatever we do with those numbers, that's what we're analyzing. And we generally are going to filter, we're going to group, and then we're going to aggregate these numeric columns. That's the world of flat spreadsheet-based reporting, which has its place in the world. And it's a very simple approach. However, when you're dealing with a large volume of data and you're working with more complex data structures, this does not meet all of those business needs. So let's move on to the next view, and that is the dimensional model. So if you're new to business intelligence a la Microsoft, then the dimensional model is really kind of data modeling 101. This is the thing that you need to master and understand where to use it, where to perhaps make exceptions in your data modeling journey. So we have the concept that we call a star schema. Now, this is not a new concept. This has been around for a very long time. The idea behind a star schema is that we define business facts. We'll talk about that process. And then those facts are grouped by, filtered by, related to dimensions. So here is a materialized star schema in the sample database that I'm going to show you. Now I have a few different fact tables, but those facts could be things like online sales and store sales. They could be transactions. They could, or at least the summarized view of transactions. It could be a lot of things, but there are always numbers associated with facts. And generally we have keys that allow us then to relate those facts to individual dimensions. And these are 4 different dimension tables: customer, product, order date, and store in this very simple example. So using a dimensional model is a general best practice. And what I mean by that is that 95% of the time, this is going to be the go-to modeling approach for analytic data, for business intelligence data. Now, the dimensional model doesn't necessarily meet all of the needs, but it is a starting point And it really should be the place where you start when you're creating an analytic solution, meaning generally we're summarizing and aggregating across these different dimensions. You get improved performance, accurate results, and but it's not an absolute for simple attributes. What I mean by that is that we might have attributes associated with a fact. So let's say that an order could be active, inactive, or unknown. So on every one of my order records, I have active, inactive, or unknown. Do I need to put that into a dimension table so that I can completely adhere to the rules and the concepts of dimensional modeling? No, there are exceptions, and the tabular modeling engine has a place for those exceptions. So you don't always have to pound everything into the shape of a star. So there are rare exceptions, but they really should be treated as exceptions. So where did these dimensional modeling rules come from? Who defined them? Where can you find them? If you've been around the industry, you know that the go-to group, the go-to people who have really fleshed all of this out and have written a number of great books on the topic are this group of people. Not to be confused with this group of people, though the family photo might look very similar. All right, so this is the Kimball group, and the gentleman in the center below is Ralph Kimball. Over the course of about 30 years, Ralph Kimball and his consulting group, the Kimball Group, have written numerous books on the topic of I'm looking for my copy of the Data Warehouse Toolkit. It's not right behind me, so yeah, no, there it is. So here's the Data Warehouse Toolkit. There are several editions of the Data Warehouse Toolkit, and if you're new to data modeling, I would strongly suggest that you pick up a copy of this book, get an online copy, or you can go to the Kimball Group website where a lot of this information is shared. Now, I'm going to walk you through the process very, very quickly. There are a lot of good resources for dimensional modeling available through different organizations. We teach a course on dimensional modeling. We talk about applying dimensional modeling to SQL Server, to Power BI, to analysis services. But the process is very, very simple according to the religion of Kimball. You select business processes, whiteboard that, talk about it, make sure you understand at a high level all of your business processes. You declare the grain of your data across those processes. If we're managing orders, what's the grain of an order? Is it at a date? Is it at a time? Is it at a week? Is it at a month? Is it at a geography? Is it at a store? Is it an online sale, etc.? Across all of those dimensional concepts, what is the lowest level of grain that we care about? And keep in mind that the higher level of grain means less rows in tables, less work for the modeling engine, faster performance. So there's always this trade-off between details and summary, and it's all measured in levels of grain across each of your dimensions. Identify the dimensions, identify the facts. So 4 steps, very simple. Once you get into the weeds, it gets a little more complex and you have more work to do. Load the detailed atomic data. This has to do with the level of grain again. Into your dimensional structures. You build your dimensional models. Now remember that the religion of Ralph Kimball is 20, 25 years old, but is as true as it ever was. The reason that this is important and related to Power BI and analysis services is that the product teams at Microsoft generally have built their products on top of these principles, even though the Kimball Group actually retired 5 years ago, but they left a very, very strong legacy. Number 3, ensure that the fact table has an associated date dimension table. This is a very important concept that I'm going to show you. Ensure that all facts in the single table are at the same grain. I'm going to go ahead and just kind of finish out the list here. We talk about different types of relationships, cardinality. Are there any many-to-many relationships? So a doctor can practice at multiple facilities. And so if we need to model that data, we've got to figure out how to assign a doctor to multiple facilities, clinics and hospitals. And so a doctor does not have a one-to-one relationship or a one-to-many or a one-to-many relationship. That's a many-to-many relationship. And then make sure that anything that you need to group by, filter by, or relate between these different tables has a column represented in the dimension tables and in the fact tables. And then we're always going to be evolving this. And in the business intelligence world, that's an important thing to understand, is that PI projects never end. They're always being adjusted. They're always going to be evolving. So you need to use an iterative approach, a phased approach, but not a waterfall. You don't get all of the requirements up front, spend all of your time doing that, do all of your ETL work, all of your modeling work, all of your reporting work. It needs to be iterative. All right, so let's get into the weeds and talk about building a data model, and then I'm going to show you some examples. So an important concept is the idea of role-playing dimensions. And I'm going to pause just for a second and look over our questions real quick. I see Todd, DBATM restricts access to source tables. They create semantic views. These views appear to have a SCAR model. I'm going to go back, and Todd, I'm going to address that as we talk about working with data sources. And at the end, we'll talk about sharing the deck and where you can go for resources. Okay, role-playing dimensions. So in this very simple example, I have on-time flight information from the FAA. The concept of an airport can play two different roles in this scenario. Airplanes leave from an airport, they arrive at an airport. As far as flights are concerned, a flight leaving from an airport, that the airport in that scenario only plays one role. That is the departure airport, as opposed to the arrival airport. I only have one physical airport table. But in my semantic model, in order to say I want to be able to select the region of any airports where flights are leaving from, I want to know how many flights there were, how many different kinds of flights there were at a different time of the day. Those are my departure airports. And so in this scenario, I would have two separate tables materialized in my semantic model based on the same base airport table. Same could be true of dates. Now in Power BI, if I have one date table that has multiple keys in a fact table like sales, Power BI is going to automatically create one active and then multiple inactive relationships for each of those foreign keys in the fact table. And we'll talk about active and inactive relationships. To be able to create a role-playing dimension for each of the date foreign keys in my sales table, order date, due date, delivery date, I would create three separate instances of my date tables. That's really the concept of a role-playing dimension. And in Power BI, it essentially means that I'm going to go create a copy of a single table within the semantic model. It does use up memory, but it gives us the ability to filter and group on those tables as they play those different roles. All right, and I'll show you an example of that. Bidirectional filters, this is an important concept. Bidirectional filters give us the ability to filter records in either direction. I'm going to pop over to an example and show you an example of a bidirectional filter. The data model that I'm going to show you is, it's a model that I've actually published publicly that you're able to get to. If you go to my blog, this is the COVID-19 Power BI report that I've been kind of working on over the past month or so. This has current data from Johns Hopkins University. The data is gathered from the CDC and the WHO, so the World Health Organization, and the US Centers for Disease Control. And this data is actually updated every day, and it has current statistics, or at least within 24 hours. Current statistics, you see that in this desktop version, I'm a few days old because the numbers are a bit low. But I wanted to show you within the data model, I am storing case data at a county and or state and or country level. And that's the way that the data is coming to us. In some regions, it's at the country level. So for example, in Europe, we only have data at country level. In Canada and Australia, for example, we have data at a state or province level. And then the United States, we have data at a county level. Because of that mixed grain, what I needed to do is create a bridging table at that level of grain. It's actually at the, in this version of the model, it's I was going to say county, but it's at the state level. And, but I do need to relate that regional information to world populations only at the country level. So the way that I do that is I build a dimension table at the state country level, which is called country state. I also have a table that is really just a distinct list of countries to bridge this to my population data. So these are world populations. Well, in order to select a country and to see populations and COVID cases, I have to be able to filter in both directions. So you can see that this is a one-to-one. So in the population by country table, I have one record per country that relates to my country reference table. So that's a one-to-one relationship with a bidirectional filter. And then from country, I need to be able to filter states by country and then states to case details. For our purposes, let's say that we're at a state level. And so this has to be a bidirectional filter. What that means is that if I select a country, I need to propagate that selection, that filter, to this table, and then propagate the filter down to the case details. You can see here in this one-to-many relationship, that is a single direction filter. That's kind of out of the box. That's the thing that you get when you build a relationship. But I needed to change this relationship to bidirectional. Now, I remember 3 or 4 years ago attending a session at the PASS Summit that Alberto Ferrari was giving. And Alberto was trying to make the point that bidirectional filters were very costly. And I remember him, and I love to quote Alberto. I remember that he said, if you use a bidirectional filter, you will go to hell. And he was making the point that it's not always a good thing, and there is a performance cost, but sometimes it's necessary. So check your salvation at the door when you use bidirectional filters. And yes, you can get inconsistent results if your data is not modeled correctly. So you need to be very, very careful with bidirectional filters. To the comment of inconsistent results, let's think about that. So if I am reporting at a state level, which is what my case details are stored at for a lot of regions, if I select a country, I'm going to get population for a country, and then I'm going to be comparing that to a state, which means I would get that population repeated for every state. So that's an example of where I might get inconsistent results. All right, back to PowerPoint for now. So those are bidirectional filters. Oh, look, I'm showing you a screenshot of exactly what I was talking about. All right, many-to-many relationships. I'm just going to talk through the concept of many-to-many relationships very quickly. It can be a complicated topic, and there are a couple of different approaches. If I have because I was supposed to build that slide. If I have two tables who have an inferred many-to-many relationship, I may have to build a bridge table to associate those two tables together. Now, earlier I was using the example of doctors and facilities. In my mind, this is a very easy concept to understand. A doctor can practice at multiple clinics. He or she could practice at multiple hospitals. And so in order to assign a doctor to multiple facilities and to be able to say at this facility there could be multiple doctors, I would have to have a bridging table if correctly modeled. Now, Power BI actually gives me the ability to go grab a key column and drag it into another table where we don't have a distinct set of keys, meaning that we could have multiple doctors over here, multiple facilities over here. And if I, let's say that add the facility, I have, yeah, this is a horrible example. My screen just went black. Okay, I don't know if you all experienced that, but my display went black while I was presenting here. Anyway, Power BI gives me the ability to actually infer a many-to-many relationship, but it's not a feature that's recommended. It's not a feature that I use. I would build a bridge table, and just going back to, let's see what happened. PowerPoint is still open. But if I wanted to select, let's say, an account, and I want to see the customers associated with that account, this relationship is not going to work, this one right here, because the natural filtering direction of a relationship is in the opposite direction that I need it for. So if I were to select an account, I'm not going to see the customers associated with that account unless I make it a bidirectional filter like this. Okay, so in this case, it's customer to account. I'm going to select a customer. I want to see the associated accounts. That has to be a bidirectional filter so the filter can flow in this direction. All right, so who needs relationships anyway? So I'm going to walk you through some demonstrations and show you where we can do some advanced modeling techniques by kind of adding layers on top of a star schema model. We're going to start by talking about disconnected tables. Then we'll talk about driving dynamic calculations using a disconnected table in concert with the DAX switch function and the selected value function. And then we're going to get into the weeds with some business applications of these concepts. And get my slides to advance. All right, let me just look over questions here real quick before we jump into this. All right, thank you for your comment about bidirectional filters, Rosemary. I believe that this session is being recorded. I'm not quite sure what the logistics are for playback. Crystal, if you're there, feel free to comment on that. And I believe that they're just available on our website. Ricardo, there are a number of techniques that you can use to avoid using bidirectional filters, and it would kind of require us to get into the weeds, but you're right, it's not always necessary. Let's see. Do you build a bridge table in Power BI? What if the source model cannot be changed? You can build your bridge table in Power BI. So you can create a derived table in Power Query and using a merge, and then materialize that as your bridge table in your data model. And you can also do it in DAX. I would generally do what you can in Power Query. So let's just review that very quickly. If I need to derive a table, so I have the components of that table through joins and merges, I could derive a bridge table that I need. Where can I do that? You could create a view within your relational database. If you don't have permission to do that, you go to your DBA, ask them to create a view, and then you can materialize that just by importing it. If you don't have the ability to do that, you can use Power Query to merge two tables together and materialize that merged table as a table in your data model. And you actually have the ability to do that in DAX as well. And I generally would not use the DAX option. I would generally use Power Query to do that. All right, what's the deciding factor to use analysis services over Power BI for tabular model? Oh my gosh, that could be a very deep discussion. Analysis services supports things like source control and large models. However, Power BI in premium capacity also supports very, very large models. Without getting into the weeds in that discussion, because there are a lot of deciding points, and it's also products and technologies that are rapidly changing, I'll say this. Power BI is the product that Microsoft is paying most attention to. They've essentially moved those product teams from the SQL Server product group into the Power BI group, which means that analysis services, both Azure Analysis Services and Analysis Services on-prem, will continue to be supported, and we'll see new versions. However, Power BI is getting all the love. In the past, Power BI has been the lighter weight self-service tool. However, now with premium capacity, the XMLA endpoint, incremental refresh features, Power BI is quickly becoming the go-to tool for data modeling and where to build your data sets. Now, we're going to have interoperability between analysis services and Power BI. And the XMLA endpoint is kind of the critical feature or capability that, I don't have time to get into that, but check that out and understand it. I'll be blogging and doing some video posts on using the XMLA endpoint, migrating models between analysis services and SSAS tabular, etc. Okay, I see some very long questions, and we'll try to get to them at the end. All right, let's just jump into some demonstrations. So, where do we use disconnected tables? Now, I'm going to jump over to this Power BI file. All right, my objective is to create a dynamic measure that allows me to be able to choose a time series period, and then to be able to visualize a different version of a time series in a single visual. Let me show you the outcome first. So I'm going to go find my dynamic time series right here. All right. I'm going to just deselect everything in this slicer, and let's see, sales time series. Let's go back and that's not the one I wanted. Yeah, we'll go ahead and I'm going to change this visual, and let's take, hope I'm doing this right. We take period off of columns. Yes, okay. So I have already in my data model created a number of time series measures. Now we're measuring online sales. So I have my online sales quantity, and we'll look at the measure right up here. You can see that that's just simply the sum of the quantity column in the online sales fact table. Now, I have also created a number of time series versions of that measure. So for example, in the month to date measure, excuse me, I've used the total month to date function here against my online sales quantity measure. I have to use my date table in order to get the total month to date. And that's exactly what I've done here. So in my matrix visual, I have my date hierarchy. Here you can see the individual dates. And so here you're just seeing the online sales quantity. Now, if I were to add my month to date, you would see that that accumulates. So the numbers just get bigger over the course of a month. When we get to the end of the month, you should see that the numbers start over again and continue to accumulate. Well, that's great. I can drag my prior year, my year to date, my same period last year, all of these different time series measures that I've created into this matrix and create individual columns. But what I want to do is I want to be able to dynamically select a period, and then I want this measure to change accordingly. So let's go ahead and take that off. And I've created a dynamic measure that does this, and it's driven by a disconnected table called selected measure period. To show you that part of the expression here, you can see that I'm using the selected value function to say, all right, which period did the user select? Which periods currently has filter context? If a single period has been selected from that table, then get that value, and if it's current, then return this measure value. If it's month to date, return this measure value, etc. Let's go take a look at the data model. And you can see that that is just a table floating out there all by itself. It's not related to anything. So this is an exception to the typical relationships that I would create in a model. How did I create that table? I actually just typed in the values. I used the enter data feature to create the table. And if we look at the periods, I just keyed in current, month to date, year to date, same period last year, prior year, and fiscal month to date. Those are just values that I want to appear in a slicer or in a group so that I can use this measure. So if I choose current, that's going to return the online sales quantity. If I choose month to date, then that's going to return my month to date, or my prior year, or my same period last year, or my year to date, or my fiscal month to date. Now, because I've placed this into a matrix, I can also place this period column into the columns group. And now if I select, I'm holding down Control, if I select multiple periods, that's going to generate multiple columns. All right, so that's how we can use disconnected tables. I'm going to show you a more advanced example of a disconnected table. I would like to see the orders that are due for delivery that have not yet been delivered. And I want to be able to do that in a range of dates. So let me give you just a little more space here. I know that's kind of hard to see. So from July 24th to October 7th, I have 987 orders that are pending delivery, meaning that the order date is on or before 7/24, but the delivery date is on or after, I believe after October 7th. So how does that work? Let's go ahead and just tease this apart a bit. So if we look at this column visual, you can see that I'm using a measure called online pending delivery. I'm also using a disconnected table on the x-axis called select effective date. Well, let's just go back to our model. You can see that there's select effective date. If we go and look at that table, you can see that it's just a list of date. Essentially what I did in Power Query, I referenced my date dimension table. I only kept the date column, and then I materialized this into the model. It really was that simple. Let's go back to the visual. and take a look at the online orders pending delivery. So utilizing that disconnected table, I'm going to reclaim a little bit of horizontal space so that I can zoom in on this DAX here in the editor and just point out what we're doing here. So the first thing I'm doing is I'm declaring a variable. This is just for convenience sake. It makes my DAX code a little easier to read. The first thing that I need to do is figure out if I have, here we're always assuming that we have a single effective date selected. Since I've placed the effective date, the date column from the select effective date table onto the x-axis of that column chart, there's always going to be a single date when this calculation is performed. Knowing that, I'm just using min. I could use selected value as well. I could use a combination of has one value and min or selected value. In this case, I'm going to assume that there's always going to be one date in context when this calculation is done. I'm getting that date, and then I'm going to say, okay, we're only interested in the number of orders that are out, so I'm going to count the rows in the online orders table. I'm going to throw out all of the filtering that's going on because I always want to see the count of all of my orders, regardless of any other slicers or filters, so I use the all function to do that. And then I just do some comparison logic here saying where the order date is less than or equal to that date, again on the x-axis, and the delivery date is greater than that selected effective date. So it really is that simple. And like most things in DAX and data modeling, you can spend a lot of time working through and troubleshooting these things, and the answer is usually pretty simple after you figure it out. All right, so that is how we use disconnected tables along with the switch statement. Trying to jump back to PowerPoint here. There we go. Direct query and composite models. Now, this is a deep topic, and let me just kind of introduce the problem space before we talk about this. Direct query. If you don't have a background in analysis services or tabular modeling, let's say that you have a background with SQL Server or another relational database product, chances are very good if you have deep SQL skills and already understand relational database concepts, you come to a product like Power BI or analysis services, and then learn that there's this option called direct query, which effectively allows you to not import data into a data model and then define relationships, but just use your existing data model that exists in your relational database product. Kind of the natural reaction there is, oh my gosh, I don't need to learn DAX, I don't need to do data modeling in Power BI, I can just use my data warehouse or my data mart and then build reports on top of it. And yes, you can. But if you do that, there are a lot of DAX functions that are either going to not perform well or may not work simply because we're not utilizing the in-memory tabular modeling technology that Power BI is based on top of. Now, direct query has its place in the world. And generally, it's so that we can create composite models. So if you have detailed transactional tables that we're not going to do a lot of aggregation over the top of, you can reference those tables using direct query, meaning you're not importing and storing a cached copy of that data. But then for the other tables, you do bring those into the tabular model. They sit in memory, they get compressed, they have relationships defined, and then you can do your grouping, filtering, slicing, and you get all of that very fast interactivity because that data is sitting in memory. So I'm going to actually show you this data model. I'm just going to show it to you quickly because it's not the topic that we can really get into the weeds with. But know that this is an advanced capability that allows us to get kind of the best of both worlds. One, we have imported data sitting in memory, as I just described, all of the goodness that comes with that. Yes, you need to learn a little DAX. Yes, you need to understand data modeling within Power BI or analysis services. But let's say that we've got a transaction table with billions of rows. I don't want to bring that into memory, use up all of that memory on my server in the Power BI service. We can allow a user to drill through to related details by using direct query. That's what a composite model is all about. So let me just show you a quick example of a composite model. Again, this one's very simple. It's just really kind of for demo purposes. But here you can see that I've brought in the same table in this scenario. In production, typically, your direct query table would be more details. But if we look at the properties for these tables, you can see that every single table in my model was imported using Power Query and then brought into my data model as I normally would use Power BI. But this table, when I connected to it, I chose the option. There's just a little radio button there, import or direct query. I chose direct query, which means that this table does not get materialized into my model. That data is not stored in the model. It remains in SQL Server, and I have a connection to SQL Server. Now, when I deploy this model up into the Power BI service, into the cloud, I need to have a gateway set up so that if a user browses to that table, if I have visuals that are based on that table, that it can translate the DAX query from the visuals into T-SQL, and that gets processed down on my server, and then the data flows through the gateway, and then I see the results. So in a nutshell, that is how composite models could be created with direct query. There's a lot to that topic that we could get into if we had time. All right, let's get back here. So I had a bullet point earlier. In fact, I'm going to go back to this slide. Who needs relationships anyway? I want to make the point that relationships serve an important purpose, but they are not an imperative. Many times when you're modeling your data, as things get more complex, you may find that you just can't pound that table into your dimensional model and enforce relationships on it. There are a variety of reasons that the relationships can get in the way. And I just wanted to show you an example of a model that makes this point. Okay, so I'll just point out that we've got a whole bunch of visuals on this page, and I can change my date range slicer, and you'll see, I don't need this panel. You can see that the data interacts. You can see that I get the cross highlighting and cross filtering that I'm used to seeing within Power BI. All of this is working as it should. And so you might think, oh, well, obviously here I have product category information, subcategory information, I have dates. There must be a fact table that's related to a date table. There must be a fact table related to the product table, related to geography. But I just wanted to show you that with one exception, there are no relationships in this model. Now, I'm doing this only to make a point, not because I would generally do this in production. It's very possible and actually quite easy in DAX to work without relationships. So in my online sales quantity measure in this model, I've written some simple DAX. So what I'm saying is don't rely on relationships because they don't exist in this model. Go calculate the sum of online sales quantity and go get the customers from the customer table that are in context. In other words, if the customer table has been filtered, go get that set of keys from the customer table and use the treat as function to cast that set of customer keys onto the online sales table. And so treat as allows me to say, just hop from one table to another without worrying about the relationships. This gives us a tremendous amount of power to be able to work without relationships. All right, I see a whole bunch of questions. All right, and I'm going to come back to them because we're wrapping up and we've just got 6 minutes left. Let me go ahead and go to my resource slide. I'm going to jump ahead. So this slide deck will be available through the presentation. Crystal, are you there? We had a question about both where to find the recording and resources. I will make this available through my personal blog, just so I can give you an answer right now. And Crystal, are you there?
Yeah, I'm here. The recording will be available tomorrow around noon, so you guys should receive the email link in your email box with the recording, so you guys will be able to view it. And all of our webinars are on our YouTube page as well under free training, so feel free to listen to that.
Can we share the slide deck file as well?
We don't share the slide deck file, but you guys will have the slide deck in the recording.
In the recording, okay. So because I didn't know the answer to this question, this is why I left the full URL in these links. And so you'll have to exercise your typing fingers a little bit, but most of these resources are easy to find on the web. Again, look to the Pragmatic Works site where we have our Azure Everyday videos. So every day we actually share a short 2 to 5 minutes of insights on related topics. I've done a number of those on topics related to data modeling. Of course, these recordings and other related recordings. And then I will share the deck and a copy of the Power BI file that I've been using through my personal blog. And again, you can find that on the opening slide. So with that, we have a few minutes left. So let's go ahead and review our questions before we wrap up. So I'm going to scan the list here. Crystal, if there are specific questions that you can help me call out, feel free to do that. We've got a whole bunch of questions here. So Richa, I appreciate the resources there about using relationship and some of the other techniques. A lot of content there that I can't necessarily read through right now. For Power BI use, can I just use the star schema in SQL Server instead of analysis services? So Ricardo, I believe the answer to that question is, do I use direct query just to use the existing relationships in star schema in my data model? Yes, you can, but if you use import mode, you're going to get better performance. You're going to be able to build more complex and perhaps more insightful measures using DAX if those are requirements. I would default to using import mode to bring that into the tabular model inside of Power BI. You had mentioned analysis services, and I think that means using the tabular model in Power BI. You certainly don't need to use SQL Server analysis services outside of Power BI. It's just the same modeling technology that's baked into Power BI. Does Power BI handle slowly changing dimensions? Yes, we can model to support slowly changing dimensions. Very quickly, the question there is, do I use a parameter to capture and snapshot the state of a dimension at a point in time and then bring that data into the model, which means that the changing dimensional is frozen in the model, or do I bring in all of my SCD records? Let's say it's an SCD type 2 where I use an effective date? Do I bring all of that into my fact table, and then do I use a date to slice that effective date? I could do it either way. And if you need to use the latter, you certainly can. It's a technique, it's not a feature. And that's something we would need to dig into quite a bit to get into. So I'll say yes. Will you show a data model that's bad? No, I only showed you good ones. I'm sorry, we don't have time to dig into that a little more, but if you could repeat the qualifier for making the decision when to use the composite model. JM, I'm going to say that the composite model is something that you're typically going to evolve a solution into. It's generally not something that I do up front, because the composite model gives us the ability to drill to details. We can typically add those details later on. Now, I'm a firm believer in two different concepts. One, plan ahead and understand your requirements, and two, that's not always reality. And we need to bite off enough that we can chew, and then work in iterations to evolve a solution. The problem with that is that oftentimes we don't meet all of our requirements when building the foundational solution. So through those iterations, oftentimes we end up kind of throwing some things away and starting over again, and then we kind of hone and build the right solution. So composite models are not used that often, quite honestly, but it's something that we typically evolve into. The URI for my blog is on the first slide. It's SQLServerBI.blog. The advantage of productionalizing a Power BI model as opposed to SSAS. Sachin, that is an excellent question. We're a little over time, but I'm gonna answer it. Microsoft is moving in the direction of making Power BI the product that you will use for everything. Now, there are lots of reasons that's complicated right now. My direction is that I generally use Power BI even for enterprise scale models unless I have a good reason to use SQL Server Analysis Service. Now that might be that I have enterprise scale requirements that require low-level partitioning, a lot of control over partitioning. Now I'm working with a couple of clients right now where we're using either incremental refresh, which is now a Power BI Pro license feature. In the past it was premium only. Or we're actually using the XMLA endpoint to migrate an SSAS database into a Power BI model, and then we can actually create partitions. New feature in preview, not in general availability. Well, it is general availability, but it's preview. So we're moving in the direction of using Power BI for the enterprise. But because analysis services has been around for a very long time, it still is kind of the go-to technology for large enterprise scale solutions. Stay tuned because that's changing very quickly. All right, well, I think we're out of time. So with that, I'm going to go ahead and wrap up. If you ask questions that I wasn't able to get to, you're welcome to reach out to me. I'm in the middle of a lot of projects right now, very busy, so I can't promise to get back to you right away. Through my blog or through Twitter, you're welcome to reach out to me, and I'll get back to you as time allows. With that, I thank you very much for your time and for attending, and stay safe right now, stay socially distanced and isolated, but we do appreciate your attendance. Have a great day.
All right, thank you, Paul. And like I stated before, our webinar, you guys will receive this webinar tomorrow in your inbox around maybe noon or 1 Eastern Standard Time. So please look out for that. As well as if you guys have any questions for Paul or myself, please feel free to shoot us an email. We'll be happy to help out. We hope you guys enjoyed the webinar. I hope you guys have a good rest of your Tuesday. And like I also stated, all of our webinars are on our YouTube channel. Just go under Pragmatic Works and go under free training, and you'll see all of our past and current webinars. Thank you guys so much. I hope you guys have a wonderful rest of your day.
Thank you, Crystal. Bye-bye, everyone.